Okay, that's very nice. Um, I think the event starts automatically. I'm not sure if we should wait a bit more before for people to join. Maybe we'll wait just 1 more minute and then we'll just start. If you can write in the meantime something in the chat so that I know that you can hear me, that's perfect. Great, thanks. Amazing. Okay. So hello from Munich. So I'm currently in Munich, and great to see that Quentin, you're in Annecy. So okay, I think it's for already time to start. So I will just start, and people will slowly join if needed. So okay, let me just see my slides. And okay, so welcome to the first Pruna webinar, and I can promise that there will be some others, and there is already a new one that is scheduled in a couple of weeks, so you can register also for the second one. So today I'm really happy to show you a bit what are the cool things that we did in 2024 and what we'll do also in 2025. So actually, before explaining what we've done and what we will do, it is important to know what is our mission. And at Pruna, our mission is kind of simple. Our mission is to make great AI accessible and sustainable. In this case, great AI means be able to guarantee high performance and reliable performance for all AI models so that we are sure that all these models are not producing negative effects and bad consequences for people. Accessible AI means that everyone should be able to use AI models by, for example, lowering cost and complexity when using AI models. Because of course, we don't want to have like only AI models being used by GPU-rich people and only people that have access to the understanding of the technology. And also like sustainable AI, which means to protect kind of natural resources by lowering the waste of hardware or energy and CO2 emissions. Since of course we don't want like all these the AI models to consume all the compute that the planet can propose. So to achieve this, what did we do in 2024? At the core of our achievement is actually a first thing, which is that we build the Pruna package. And the Pruna package does the following. It can take any model as input, for example, image model like Flux or Stable Diffusion, or like video models like Unyuan or Stable Video, audio models like Whisper, or text models like Llama, and then take them and pass it in the smash function that combines a lot of compression methods like pruning, quantization, caching, and compilation in order to return a smash model. The smash model just behaves exactly in the same way as the base model, except that it's smaller, greener, and or faster. And this is exactly what we have done so that all the models have just a lower cost and everyone can just run AI models. So we really worked hard on making this accessible to anyone, and it is actually now self-served for anyone. So anyone should be able to install the package with this simple command that you can see below. And we also worked hard on making a nice documentation so that you can understand how it works and how to use and compress your own models. So please check these links if you are interested in knowing more on how the Smash function works. But I will show a small demo later. One common question that we had in 2024 was, do you lose quality when you compress your models? Well, let's check together maybe. Here you can see two images. One of them has been generated by a base model, which is called Flux, and the other one has been generated by a compressed model. So maybe if I just propose like a small survey in the chat, so can you guess which image has been generated by so which image has the highest quality? If you think that is the left one, you can write 1. If you think that's the right one, you can write 2. And if you think that this is these two images have the same quality, you can just write 3, I guess. So, of course, John, I guess that's good to. Okay, I guess most people say that it's kind of the same quality, and that's great to see this, because actually we also run this test with a lot of a lot of people, like hundreds of people, and indeed it was really hard for them to distinguish between the two images. But actually, the image on the right has been generated by the compressed model by Pruna. So somehow it answers the question that if you compress your model correctly, it does not mean that you will lose quality. But actually, what you can do is you can save a lot of time, money, and also memory, and a lot of other things. So if you want to check like more of this comparison, you can of course check some benchmark that we did on this Vercel app, where you can look at a lot of different prompts and see how the difference between the base and the compressed model. And you will see that in general, you can really achieve no quality loss even after compressing your model. So now I guess the main question is, how does it work and how can you compress your own model? So here I just recorded like a small video to show concretely how to compress one model. So in this video, I just show like an example with stable diffusion model, but keep in mind that it works with any model. It can work with LLM, video models, Whisper, and so on. So here the idea is that we just show simple steps. So the first idea is we just load the model, so which is a standard small stable diffusion model, which is represented here. And so this is something that everyone would do. And then what we do is we just generate 5 images to see, so to say, how slow the generation of one image is. So you will see approximately it will take between 3 and 4 seconds. And just so that you appreciate how slow it is, I will just leave the 5 image generation. And the next step is actually then to try to compress the model. And to compress the model, what we'll do is we'll simply define what we call a smash config, which defines which method should be used, and if we should use also a combination of compression methods. And in this case, we propose just to use like 2 compression methods called diffusers2 and step caching. And then the idea is just to call the smash function. It's just a single line of code. You call it, and in this case, in less than 10 seconds, you just compress the model. Now you can just appreciate kind of how fast the model has been after compressing the model. So in this case, we just generate again 5 images. And you will see approximately it will, in average, it will take just 1 second to generate one image. And even visually, you will see, okay, the image, they show up like much quicker, which has a very nice effect. For example, if you want to have like a nice user experience when so that your users do not wait too long for the output of the model. Okay. Just let me go to the next slide. So now the idea is by providing this smash function, so we aim to show you like a different way to compress your model. So in general, there are 2 solutions if you want to compress the model. You can do the manual solution, which is mostly, read and understand a lot of research papers, implement and test compression methods manually, integrate compression methods for your specific model hardware, test and evaluate all hyperparameters, and finally, hopefully get efficiency gains. Here I say hopefully because if you worked a bit with all the research, you know that sometimes it's hard to reproduce the efficiency gains that are shown in papers. But the alternative that we built and proposed with Pruna is actually to simply install the Pruna package with the pip install command that I've shown before, smash your AI model as you've seen in the previous video, and then get significant efficiency gains. Hence, instead of doing just time-consuming research, you can just make use of easy-to-use compressions. Instead of just debugging and trying to adapt to any hardware, so you can just use the wide range of compression methods to adapt to different models on hardware. And you can also not waste resources with suboptimal, compressed models, but just have reliable efficiency gains. And what we have done to show that this works well at scale also is we just took a lot of Hugging Face models and tried to compress all of them with Pruna. And we already reached 9,000 smash models on Hugging Face that you can try just in a few seconds there. So now the question is, this is what we've done in 2024, and for 2025, we mostly, we plan to just build on this and iterate on it. And how? Simply by listening at your comments and questions, and we design a plans to answer them. So one first comment that we had, that we heard a lot was, how can I see the Pruna code? And of course, we understand you because many people are interested to check how does it work, to get more trust, and also it makes things easier for you to debug your code. So to answer these questions, we decided to actually open source compression methods and combination of compression methods for everyone that we have at Pruna, so that you can really enjoy and see the code and gain trust in what is done by the smash function. This is, of course, a very important step for us to just show how does it work and also engage with you. Another comment that we had is, what compression methods should I use? Again, we understand you because given a large list of compression methods and all their hyperparameters, it's not easy to know, okay, which compression methods should I use, what should be the hyperparameters, and so on. So it takes a lot of time. So what we've done is actually we tested a lot of these compression methods, and actually to solve these problems, we simply plan to simplify the search of the best compression methods and the best hyperparameters, so that actually you don't have to worry about it at all. So instead, we just plan to make it automatic, and so that you can just use the smash and you don't have a smash function, and you don't have to just look for all the options. Another comment that we had a lot was, I want simply more. How can I get more efficiency or quality gains? So that's great. It means that somehow you already liked a bit what Pruna does, and you would like just to get even more gains, since it could be very beneficial for your applications. So in this case, we already tested a lot of compression methods, but we are still, constantly working on integrating new ones, and more specifically, the most recent ones that can just be published at the Best ML conference, like for example, just NeurIPS in last December. So what you can expect here is to get a lot of quantization, kernel, caching, compilation methods to be integrated to get the best efficiency gains for your use case. And beyond, of course, the compression, we also plan to add recovering techniques to make possible to increase the quality of your compressed models for the specific, data domains that you're interested in for your application. Now, another comment that we had was also what are the performance difference between the base and the smash model? In many situations, we realized that actually it's actually hard for people to evaluate and compare the quality and efficiency of their models. Sometimes current metrics are a bit complicated to understand. So you can, for example, look at generated output, but it's not super representative. You can just try to reproduce some numbers, but this is complicated. What we will do actually in 2025 is actually make available a lot of metrics that we already tested on thousands of models, and make all this compelling list of metrics accessible to you, so that you can have a nice overall view on how well does your model performs and your compressed model performs on your specific application. And finally, a last comment that we had was also how can I serve my compressed model? Often you might have like your own ML pipeline to serve your model, and you might wonder, okay, how can I put the smashed or the compressed model in my ML pipeline? So the good news is that we already did it many times for people, and we help people to do this, and we plan actually to just make all these integrations much easier, to show nice walkthrough on how to integrate, the compressed and the compressed model into your ML pipeline. Of course, this is kind of the overview of 2025. And I cannot show you, all the output that we are already working on right now. So what I would suggest you, in order to not miss, these incoming features, is simply just to join us and maybe to, follow us, especially on Discord, Hugging Face, or like any of these social media, if you want to, get updated, up to date with the latest Pruna release that might come already in early 2025. So that would be it for this first webinar. So thanks a lot for attending the first webinar, and I'm happy to take any question. I couldn't check the chat so far, so yes, if you have any questions, you can just write in the chat. You can also probably just talk, and really happy to answer them. There are also a couple of people from Pruna in the chat, so I'm sure they are also happy to support you if needed. Very good point again by Melanie. Like I can also just copy paste, of course, like all these links if you need to in the chat if you're interested. Okay. Thanks also, Antoine. So that's a good question, Quentin. So I think there are a couple of nice compression methods that we plan to integrate. I could say that there is like a very nice one that we are working on at the moment at Pruna, which is like extreme quantization that can go until 2 bits. And one of them is called Higgs, which is not already here, in Pune. And of course, if you would like to try it, just keep up to date, and we'll release it soon. So what types of models does it support? Is it any transformers? So basically, if you check the documentation, you will see that there we have like tutorials for all types of models. So you have tutorials for image generation models, video generation models. So for these models, for example, it can be unit-based models, for example, for image generations like Stable Diffusion. It can be also transformer-based models, for example, like Flux. Also, we have tutorials for LLMs, where you can see that, of course, these LLMs are often also transformer-based models. So you have normally like a lot of compression methods that would cover like all the different types of models that you are interested to. But I would really suggest you to check the documentation and join the Discord if you have any questions when running this small tutorial. I think this was also somehow similar to the question of Naeem. Does Puna work with some specific models or not? So what we've done so far is tried with a lot of different models: image, video generation, LLMs, Whisper. It works with many of them. There is one tutorial for each in the documentation. You can just try it. It should take really like just a couple of minutes to try it. And if you meet any problems, you should not hesitate to just engage in Discord. Yes. Good point, Quentin. So it works also so you can just install locally Puna and it will work on your side. So I'm not sure. So one other question was, what about LLM, especially multi-language model performances? So if you check, like, again, what we've done on Hugging Face and so on, so you will see that we have a lot of quantization methods that you can apply to LLMs. We have also like kind of compilation methods and so on that can be combined. And in this case, depending on how strong you want to go in terms of efficiency gains, you can get different types of speed ups, but and different trade-offs in terms of quality. But if you just do it not quantize it to just 0 bits, which is kind of not possible, you will be able to just maintain the performance of the compressed model. Okay. Are you constantly updating the optimization methods on the new models that big companies are releasing? So actually, so what we do is really we automatically look at the new models and try to compress them. So the idea is, like, all the compression methods that we implement, we try to make them as agnostic as possible to the model architecture. Sometimes it's not possible to make it directly agnostic to any architecture, but the idea is that we adapt it really to different model architectures. For example, the Llama models, we could compress it when it was the day it was out, and actually, if you want to, you can also do it yourself by just installing Pruna. So something that is important is to know is that there might be quality loss if you go too extreme with the compression you would like to go. So you should not be surprised to sometimes, if you compress it very too strongly, you might get quality loss. That's why also it's important sometimes to evaluate the models. But if you just do it kind of as suggested, for example, in the documentation and so on, you would get like almost no quality loss. Are there some other disadvantage of compressing the models? So I guess in many cases there are not so many disadvantage to compress your models, because you would just get like more efficient models and so on. The main thing you might have to change is in your ML pipeline, just switch the base models with your compressed model. But again, if you have any problems, feel free to ask us concrete questions about things that are blocking you. So what input format does Pruna accept? ONNX, safe transfers. So basically you can load any kind of PyTorch and Hugging Face models, and this should work. We don't manage ONNX models as input at the moment. Okay. I will take then the next question. What Pruna package used to create small LM? Also, where can I find its repo or collab? So I guess you might refer to like the recent blog that we've done on small LM, where basically we simply, if I go back to the slides, so we simply use like the package that we've seen at the very beginning. So here, this package. So how you can install it is simply use pip install, and you should be able to compress small LM exactly in the same way as we've shown in the blog at Pruna. So basically, there are like multiple quantization methods, AWQ, HQQ, and so on. And if you want to reproduce this, you should be able to reproduce it simply with the package. Okay. Now we look at the next question from Jose. Okay. Sorry. Are you planning to automate tests to evaluate the performance on the model? Do you do it already? So right now it's not on the current version. So if you install Pruna, you would not get like all the automation for the evaluation and so on. But this is really something that we are working on and will release in 2025, make the evaluation also of the model automatic and easier to understand for people. So meaning like you will be able to compare easily the speed, the memory, the quality in different aspects of the model and so on. So if you're interested in this feature, feel free also to share more about your use case on Discord. But this is definitely something also that we release, I would say, in the first half of 2025 or even earlier. So next question is, how does Pruna differentiate itself from Olama and the likes? So I'm not sure if I get the likes. Okay, I can see ease of use, but would like, so kind of Pruna is more like complementary with all these serving tools like Olama, TGI, or Conf UI for image generation models. So the idea is that all these things, they allow to serve the model and make your model work in your application. But what we do is we do the step before, which is compressing the model. And then you can take these compressed models and put it in Olama, for example, to get the model which is now served on Olama even more efficiently. So this is kind of a combination, and this is something we work on to show how to integrate, for example, to serve your model in the best way so that you can take your compressed model, put it in Olama, and make it work. Okay. I see that someone is typing. Are we planning other collaborations with Hugging Face? So we are in discussions to work on a couple of things with Hugging Face, but nothing that we can really say right now. But I can say that we are still like active discussions with them. I see that Blay is typing something, so we'll just. I'm not sure if I missed any questions. Just let me know if I missed one question. Does the Pruna package also do some retraining, fine-tuning after applying compression methods? Does that make sense in your experience? That's a very good question. So right now, in what we've done in 2024, it does not do fine-tuning. Like, for example, the common way to do it is to use LoRa or QLoRa. It does not do this right now, but this is on our roadmap for 2025 to just work on this. So here, this is this point here, working on what we call recovering techniques. And so in some cases, it really does make sense to also combine, compression methods with recovery methods. If I can give some information on this, is usually you don't need to have a very general model being able to do everything, but you just need to have a model being able to be good at some specific task. For example, on medical data and so on. So what you can do is just specialize the model during the compression so that it focuses on retaining the knowledge for this specific data domain. So your model specialized on medical data does not need to know everything about the president of the USA, for example. So I would like to compress an LLM so it works on mobile device, offline, and on Cloud Run. I heard you mention something about. Okay, sorry, it goes too quickly, so I can't read. I heard you mention something about hardware. Can you elaborate more on that, please? So right now we don't focus a lot on working a lot on like many edge device, but we focus on being able to work a lot on like different GPUs, on also like GPU types and so on. So this is not. We have a couple of methods already that allows you to compress your models, for different CPUs and edge device. But it's something that we don't have like tutorials on it yet. If this is something that is really interesting to you, I think it would be very nice, of course, to hear about like what would be your needs and what do you mean in terms of hardware that you would be interested to focus on. Okay, next question. Are you planning to work with hardware providers to easily integrate their models on their chips? Qualcomm, NVIDIA, Intel. So actually, we already have some support from some hardware provider, like for example, NVIDIA helps us. Also, like people like AWS, they have also their own hardware and so on. So we work with them, but at the moment we collaborate just on being able to support their hardware, so that works. The compressed models are also working on their hardware. I think that would be kind of it for now. If you have specific chips that you're interested to run your model on, of course we are interested to know about your use case. Okay. I'm just checking if there are like some other questions. I think otherwise most of the questions have been answered. Yes, that's a good point. So we don't have a tutorial on this, but we tested it already on like CPUs on Qualcomm device, and we have results on this. We actually did even some more tests internally on very small device like um, Raspberry Pi and so on. But these are things that we don't have clear tutorials published yet. Okay. Yes, if you have any questions, share them. Be happy to take this. So I can share the Discord link here. Okay, thanks a lot everyone for joining this webinar. If you have any follow-up questions, join the Discord. We are a lot of people from Pruna here to answer your questions, and really happy to share again, in the coming months what we've done, what we'll be doing. Thanks a lot.